Now let's try to get a snapshot of the role of that water, that precipitation that filters through and feeds our underlying groundwater, which I mentioned before in the hydrologic cycle. So here we have the gray globs illustrating regolith, and at the bottom we can see bedrock. The brown indicates mostly soil, where the blue indicates mostly water. And so one of the things you'll notice, there's two distinctive zones. And so here we have rain falling. It's going to work its way through these various zones, and it's going to settle at the bottom. Why is it going to settle at the bottom? Gravity's pulling it downward. And so one of the things you'll note is just like a cup. If I pour water in a cup, of course, it's not going to come out of the bottom. And so essentially that bedrock is what we refer to as an impervious surface in which water cannot penetrate through it. So essentially that water is going to be stored and held just above that underlying impervious surface. And so the first thing we'll talk about is the zone of aeration, that at the top. And so water works its way through the zone of aeration, but eventually is going to collect in the next zone that we're going to talk about. And so one of the things you'll note here is the pore spaces, or the spaces in between the bits and pieces of regolith, is mostly air, soil, organisms, what have you. So we'll also refer to this as the unsaturated zone. Much like a Brita, if we think about a Brita is a water filter, filters out your water. You put the tap water in the top, and then the Brita filters out, and the water collects at the bottom. Same idea here in our zone of saturation. Here the pore spaces are going to be more contained with water, overwhelmingly water in the pore spaces in the bits and pieces of regolith. We also refer to this as the saturated zone here. And so the simple idea here is the top of the zone of saturation is known as the water table. One of the things to note about the water table, it generally follows the contours of the surface, roughly. We can see that surface up there with those poorly designed trees, that green line near the top. Well, of course, groundwater flow, as far as how fast this underlying water flows, is going to depend on the steepness of the slope, i.e. gravity. Now I've taken those schematics, those models on the previous images, and I've taken them to maybe a more real-life example. One thing you'll note here is, of course, we can see the zone of saturation, the water table, the zone of aeration. You can also see how the water table, for the most part, follows the contours of the surface. But more importantly, if we look at the surface stream. So essentially, anytime you see a river, a creek or a stream, for the most part, that is simply the water table exposed. The water table is exposed and it's above the actual surface. And so a surface stream is just the water table exposed. One thing that does occur during a dry season or even a drought period is the fact that the water table is going to lower. And of course, during a wet season, that water table would then rise.